Have started the recording. Yeah, so Hrishikesh, I just invite you to start your talk on basically that using computer vision in healthcare and safety application.
Thank you, Professor Abhishek and Saurabh. First of all, I have to apologize to Saurabh. Like, this is the third month when I was part of the plan to do this, but due to one reason or other, it got postponed. So very happy that finally it's happening. Hopefully you will understand the situation in startups. It's like firefighting every day. So it's very difficult to plan for something, and we try to stay committed whatever we do, but it's difficult. So thank you for having me. And I have prepared a few slides to go through and have a lot of time for discussion in the end. Since I'm coming from the industry side, I have tried to make sure that I talk more about application side rather than the technology side. But primarily, I'm a technology person. So if you have some kind of a technology related, how the algorithms are done or how the modelings are done and how it's deployed, those kind of technical questions, I'll be happy to share as much information as I could. But the primary idea is to give you a background of use cases, safety and health related use cases, how big the problem is, and the kind of technology solution which we'll need to have in the future for a better working environment for all of us. So please let me know if you are able to see my screen. Anyone? Okay, I'm assuming my screen is visible. So first of all, thank you for joining, especially on middle of the week on a Wednesday in the evening, 6 o'clock. When I remember my own college days, almost 22 years back, I hardly joined anything at 6 o'clock. I always used to be in a field playing something or learning something on a playing field. So so thanks a lot, and hopefully we'll talk something which might interest you and which might be useful to you in the future also. A quick background about myself. So currently I'm managing this company called CerebrumEdge for last 6 years. Before that, I was doing different kind of data analytics role as senior data scientist or program manager, mostly in the field of manufacturing. So I have worked a lot with automobile and aerospace companies across the world. Also have some experience in healthcare and insurance, optimizing the healthcare data and the insurance premiums, etc. And as I was saying, like 22 years back, I was in campus life for 5 years, probably the best period which I had. So just a quick introduction. I guess it was already talked about CerebrumEdge, what we are doing. So we are a digital occupational health and safety platform. Digital in the sense like we collect the digital data and try to automate most of the processes. Website is there. If you need more information, you can go there and check. So we have two solutions line, two product lines which we offer right now. So one is related to ergonomics. So making sure that the ergonomics related injuries are minimized in the workplaces. And second is the safety. So we are trying to reduce the safety hazards which are present in the workplaces, and all the violations, capture all the violations, so that the injuries which are there, that has to be minimized. We are a small startup, but especially with the technology company, you cannot live in isolation. So we have a global presence. One of my co-founders is based out of North America, and we have a strong partnership in across Europe, different countries. So as a modern technology company, it has to be global. So you have to be a world standard, both on quality as well as technology offerings, people, everything. So you have to have a diverse and world-class team and product, and that's what we are aiming for. So this is the agenda of today. So we are going to talk about problem in occupational health and safety. So just to make sure that we understand this space. So occupational in the sense like all of us in our workplaces, and most of us are surprised when I say that more than 70% of our active hours are spent in either our offices, in factories, in classrooms, wherever we work. And the problem is like the data which is captured, especially the environment related data, what kind of safety or health impact we have in our workspaces, those are very minimal or almost negligible. So this is one space where lot of innovation, lot of work has to be done, and it's not only the startups or the corporate world, also in academia, and we have already done some partnership with different academic institutions, and I hope at least I can motivate some of you to have some interest and look into this area and have some work. So we'll talk about the problem. It's a huge problem which we are working in. Then we'll talk about some of the solutions, the existing solutions and the futuristic solutions. There are some comparisons like different solution space, how we are. So for example, computer vision related methodology compared to say sensors related, hardware related methodology, how each are placed and what are the benefit and shortcomings there. We'll talk about the limitations, and then we'll be open for our discussion. So just to give you some data, every year worldwide, it's estimated that around 23 lakhs people, so 2.3 million people, they die due to work-related accidents or disease, right? So if you just extrapolate this data to say our case, India is like 1/6 of the world population. So you can just imagine the kind of the problem which we have in hand. So it's like 6,000 deaths per day. Sorry, it's not per year, it's per day. And the injuries are almost 160 million. So 160 million people either get ill due to the working condition, or they get some kind of injury in the work, right? So either the environment is not well, or the health condition is not taken care of, or the safety aspect of the work is ignored. So we have some data about developed countries. So you can look at United States, and they estimate like their work injury cost for 1 year is more than 164 billion US dollar, and each medical consultant injuries easily go around $50,000. It's especially the places where healthcare cost is high, available but very high. The cost is also very high for each injury. So the global estimate is around 2,600 or 2,700 billion, which is people and society and the countries, they spend on work-related diseases, work-related fatalities, etc. In Europe itself, they estimate more than 450 billion per year. So this is the problem space. It's a huge problem where it has to be taken care of in the future. Also because of the population is more or less getting saturated even in developing world. In developed world already it's declining. So it's the people are getting aged more and more. So just as an example, in Germany itself, the workforce less than 30 years, right, and workforce greater than 60 years. Imagine which is bigger. So actually, the workforce, the workers who are elder than 60 years, they outnumber the workers who are below 30 years. So that means that it's not the old way where you easily retire at 60, and if you had a nice decent job, you get good pension and have a happy retired life. So that can be done only when you have a good economy and people in the workforce who are able to sustain the economy to give the pensions and other benefits to the older workforce. So some of us, at least, I guess most of us are probably very young, and it will be very difficult for us to retire in 60, right? So probably we need to work at 65 and 70, and to make sure that we work till that age, it's very important that the working conditions remains conducive for our body, and we are able to work without those pain and those injuries which kind of kill the working life of most of the workers. One additional data which I want to pinpoint is in all these injuries, more than 1/3 of the injuries is one condition, which is called musculoskeletal disorder, okay, MSDs. So more than 1/3 of injury is only related to musculoskeletal disorder. So we talked about all these estimate, cost estimate, fatality estimate, injury estimate. 1/3 is only related to uh, uh, ergonomics risk which people take in their workplaces, and that leads to multiple kind of injuries. So a little bit more information which I want to give you on musculoskeletal disorder. Some of you might have done, say, industrial engineering or doing some courses in mechanical engineering. I guess there are some courses on this where you get more information. So just to everybody give an idea about what we are talking about. So musculoskeletal disorder, or MSD, is like the biggest contributor of injuries, right? And it affects your complete body, your muscle, your skeletal system, your blood vessels, uh, uh, and most of us, especially during young day, we kind of ignore it. But as you get older and older, it becomes very difficult. So people keep working through the pains, different kind of pains, back pain, neck pains, carpal tunnel, etc. And they either they leave the workforce, they retire fast, or they move out of one job to lesser job. So this is one area where, as an organization and as a person, I'm very interested in, and we are looking at different methodology, different technology solutions, which could help the people in general to address that. Okay. One small point which I want to talk about is occupational health and safety in India. So I have not taken any data and number. I just want to give you a small information about automobile supply chain, only automobile supply chain. And the automobile supply chain, mostly the states like Haryana, the states like Gujarat, the states like Maharashtra. So forget about typical injuries of ergonomics related injuries. Those are not even captured. uh, at best only the fatalities are captured, but there are many cases where people lose their fingers, lose their hands. Even those data is not captured. So an additional thing which we'll have to do as a country or as a society, first thing to solve the problem is to understand the magnitude of the problem. And this is where the data collection and making sure that there's a transparency of the data and the magnitude of the problem that has to be captured, particularly in the context of developing country like India. So it's not typical Indian problem as such. The injury in the workplaces, which are kinds of getting avoided or not counted. It's a problem of the developing countries. So it's the problem in Indonesia, in Malaysia, in all these places. But let's remember that whatever product which we are using, it especially after the first layer of the topmost layer of industry, the second layer onwards, the safety standards, the compliance and the regulatory things, that's very poor, and it needs a lot of improvement, both on the compliance side and from the industry side as well. So that's a problem, and probably it's not like the people, most of the people, they want some kind of, they want to deploy some kind of solution. So all we have to make sure from a technology point of view is give something which is, economically viable. It does not hamper them in the work. At the same time, it makes the workplaces safer. So what's the current methodology most of the time? So current methodology is either, so this is a huge problem. Now with the huge problem, and it's not the problem which has come today. So it's ongoing issue. And being in, especially in a state like Jharkhand, I'm sure most of you must have heard stories about the accidents in mines and, different similar unsafe condition of work. So the current methodology in most of the places is, if the regulatory body is strong, they send the inspectors, they send people to make sure that the rules are complied and the working condition is fine. But it's a totally manual inspection process. Some industries, they have their own in-house team, safety team of people who are trained in environment health, excuse me, in environment health and safety. They come and kind of do the inspection, and they try to make sure that things are done in a right way. So it's a kind of the very manual process which was there till now, and which is still in the practice in most of the places. So what's the problem with the manual process? First of all, the manpower, required manpower is not available. The second, the most important problem which comes up with the manual inspection or the manual safety aspect is the subjectivity. So two inspectors themselves, they will not agree about the problem. So one person could say it's a critical situation, the other problem say it's manageable situation, right? So you don't have the data, you don't have the objectivity to come up to that kind of conclusion. The analysis is done most of the time as a reactive manner. So some accident somewhere has happened and it has a problem for the organization, then they try to either hire consultants or send their own safety in charge to do that inspection. So it's a time consuming and costly process, and always done in isolation. So the thing is like, okay, this is the old issue. What should we do now? So the modern methods, different organizations, different startups, also research centers. So they are coming with different methodologies, and the two type of methodology which is very prevalent and which has kind of got scale is one through the hardware sensors to monitor the environment, to monitor the human being, and the second one is through computer vision, right? Through the video feed or pictures which we get from there, from the workplaces. So important part about the new methodology is, first of all, it's data backed. So it's not like a subjective one. You have the data and anyone can see and review that why this thing is problematic, why this condition is not safe for the worker, why this might lead to the injuries, and more or less it's kind of a near real time. So these sensors or these computer vision methods, both of them almost work near real time. So you get all the alerts of the situations almost instantly. Then most of the part is getting automated, so it's not the manual intervention which is required. The other thing is like these methodology also give you a kind of a proactive approach. So rather than reacting to the injuries or reacting to the accidents, you basically deploy these methodologies to make sure that your workplace or your is taken care of. Since we are talking about computer vision here, so I personally work in the computer vision space in last almost 7-8 years. I got interest into when I was working in data analytics. I got into unstructured data, and that led me to work in image and video processing. So there are few advantages which comes with the computer vision methodology. One is the easily available data source. So you can easily procure all those videos. So most of the places now you will have CCTV cameras. CCTV cameras are really cheap now. IP camera is really cheap. So data source is available. If a particular case cannot be covered through that IP camera, probably you will have, most of us have smartphone mobile with very good camera. In fact, the camera is better than what is required for most of the computer vision and deep learning models. The other thing is can be done on the scale. So whether it's a one camera solution or 50 camera solution, the extra effort is very limited. So if you are able to work on 5 camera, you can easily scale the solution to look at the 500 cameras and deploy that. Then, of course, the ongoing research in this field, machine learning algorithms in labs, in classrooms, and the kind of models which is coming, that almost every month, or I would say every week, you see something which is very interesting and which you could try. Though I have to say that from a demo to actual production level of product, it takes a lot of time. So even if we are able to do a good demo in a lab to make sure that it gets deployed in the real places, that timeline is still very high. And this is one area where we think the startups are going to help a lot. They can accelerate this, especially the good technology startups. They can accelerate the technology which is getting developed in your labs, in your classrooms, in your projects, and can be deployed to the real life scenario where it can help the situation and save some lives. And with the software, of course, the hardware part is also very important, especially with deep learning methods. So if you have worked on most of the DL methods, they need a graphics card or GPU computation facility, right? Especially for those video processing which you have to do on the scale. So with the GPU now, the TPU is also the tensor platform by Google, and there are different software architectures. Some is done for some can be some of those architectures can be used by us. Some of them are right now in a closed space. For example, say the Tesla has their own GPU architectures. Apple is having their own GPU architectures, but the common out of shelf cloud servers, that's also good enough. And there is a lot of innovation which is happening in the hardware space. So innovation in the sense, like, it will make our algorithms to work faster, and the computation cost, that is going to be cheaper and cheaper, and that's what will make the whole thing more economically viable for the industries, for the startups to experiment on this part. So some of the I'm not talking about deep learning methodology, but if you know the space, so some of the models are right now very mature. So if you give the right amount of the data and right conditions, so of course the models, deep learning models are the data hungry models. So you have to give them enough data and enough jumpers to make sure that it works for those conditions. But if you do that, the models, the generic models like detection of anything, bigger or smaller, that you can get to very good accuracy, more than 99%, etc. Tracking an object through the videos, those kind of models, they are very mature. Anomaly detection across any, when you are trying to do a quality check of a product. So those kind of use cases, and through human eyes, it becomes very difficult. So I can talk about a couple of cases, especially say the painting defects on automobile, right? So when you go and buy a new car, just imagine there's a small painting defect, there's a small bubble or there's small dirt somewhere on on your car, and probably you'll like to reject that. Now, most of that inspection in many places is still manual. So those things are getting automated as we speak. It's getting to the stage where the different level of cameras are multiple cameras are looking on all those products and making sure that the quality is taken care of. So it's not only about the car, the other products also, which could be really useful and which could be critical for our use cases. Those are also taken care of. Another interesting use cases which I can talk about and which I personally participated during COVID time is social distancing monitoring. So as you know, everything got locked down in 2020 to begin with, and most of all us like to stay at home, and all of us were worried. And then some of the important stuff, some of the consumer goods companies, they had to start the operation. So after a month or so, they started up operations, but they had to also make sure that the COVID cases are kind of controlled, and the typical places where people are still going and mingling, for example, in the restaurants, in the breakout areas, in the tea coffee zone. So that's getting monitored, and the people keep those distances. So for those kind of solutions, many places people quickly had computer vision related solution where they were able to monitor the mass in large and also the distance between two persons at any point of time. And that if there was used to be any violation, that was getting relayed to a local area speaker, where it used to tell people you have to make sure that you keep the safe distance. And that was very helpful to start some of the industry which I am aware of. So there are multiple use cases like that. So the whole idea behind this is, once you have the methodologies, once you have a platform in the place, the use cases are you can easily start to. Of course, you will need data if you don't have the data for that particular use cases. But if you have the right kind of data, you can always start and scale it up. So some of the use cases, safety related use cases, which is getting deployed right now, and both through the sensors based technology and through computer vision technologies, are personal protective equipment. So making sure that the person is wearing the helmet, the safety gloves, if the person is working at height, making sure that you have that harness, right? So the fall injuries are really high, especially in the construction industry. So making sure that the people are wearing those harness. So all these use cases are getting automated. The pace is still slow, but it's going to pick up really fast and it will be exponential. So in few year time, you will see, either something is getting monitored, and if there's a some kind of violation, the alerts are going to the worker, to the supervisor, etc. The other really bigger area of concern is the moving vehicle safety. So if you look at any warehouse or most of the industrial spaces, there will be some kind of a small crane or some kind of a forklift which keep moving places, which keeps moving goods from one place to another places. And there is lot of dark zone where it can hit a person, it can hit a pedestrian, it can hit something else which could harm another person, another worker. So that's one area where a lot of work is going on. So there are sensor based technology where they are making sure that the sensors are there in all those forklifts, and they get alert when there is a danger. Similarly, there are computer vision related technology where you get feed from CCTV cameras, and the distances are kind of getting monitored. So I'll have a small video probably to show you how it's done in one particular cases. But similarly, there are other examples, especially the prohibited area where people are not supposed to go and people still violate for some reason. So making sure that those areas getting monitored. Now just imagine the difference between the manual monitoring and the automated monitoring. For manual monitoring, you need to have a guard, you need to have the safety person, constantly looking at that place. And it, even a small mistake here, it can become fatal. So all these cases have been are getting automated across the industry, and these huge cases are really welcomed. So I already talked about the CCTV aspect of this one. So CCTV, since CCTV and IP camera is now not very costly and it's almost everywhere deployed. So CCTV is one great data source. So you don't need to apply anything. You just need to connect to the CCTV, get the data, and do the analysis. Pick the use case which you want, and you can have your solutions. The other, the passive and manual monitoring, that's of course very costly and reactive process. So that's why all those AI related, sensors related technologies are catching up. The other thing is to understand the overall safety pyramid, right? So each major accident have a tons of minor accidents which are getting ignored, or people simply overlook that, saying that it will not lead to something that. So this safety parameters which we have to understand is one fatality is when one fatality happens, there are almost 300,000 unsafe conditions or safety hazard which is there in the workplaces. So the idea behind these digital technology is to making sure that you capture the bottom of the pyramid. So it's not like capturing the major injuries, capturing the minor injuries, or capturing the fatality. So let's capture the unsafe condition itself. So let's monitor the condition. Let's see like which conditions might lead to injuries or a major accident. So this kind of data can be captured only through the digital. There is no other way. Manual inspection or manual safety in charge will never able to do that. And once you have that data captured, of course, then you make sure that if it is on unsafe condition, you do a process change. You make sure that people don't get exposed to those safety risks. And if people are doing it willingly or unknowingly, then you have to make sure that there is a behavior change in the people, right? So and that has to be, it's not like one solution for all. There is customization for different places. So one small video of moving vehicle safety. So there are, as I was saying, there's a dark spots, right, in most of the places. So the vehicle is moving, it's not realizing, the person is not realizing that he is in part of the vehicle, right? And it could be, the person could be really in the danger. So there are two things which could be done here. One is the driver of the vehicle has to be alerted on time, which can be done. The second is if the person is in the zone where they're not supposed to walk, they can be alerted also, right? So all these conditions can be taken care of in a large extent. These unsafe conditions can be identified through these vision related technologies. Okay, so one thing about sensors versus computer vision is, since we talked about the both conditions, right? And we talked about the environment, how the things can be done. Now about what about the human body, right? So if we are not doing the things correctly in the right posture, that might lead to, and that only lead to, the MSD injury, the musculoskeletal disorder, which I talked about in the beginning, which is the biggest component. So that's one condition where a lot of the work has to be done. So there are again there are census related solutions, and there are computer vision related solutions. So sensor related solution, you need to have multiple sensors placed in your body to make sure that your movement is getting captured, all the body angles and biomechanics are can be tracked. So that's one way of doing that. Though when you are using those sensors in your body, it's a kind of intrusive, right? So you have to wear every time you are going to do the analysis, and of course it's much more costlier than computer vision technology. So computer vision technology is right now reaching the level of accuracy of sensors related technology, and it's also giving the similar or much better overall the risk profile of injuries, especially when you are in your workplace doing some kind of a work. So this is just one example of estimating a human body and different joints and body postures from a simple two-dimensional video to a three-dimensional uh, kind of augmented reality space. So you are taking a two-dimensional video as an input, running your computer vision and deep learning related models. Now there are multiple models which run to get that. Right? So if you have to have a solution, there is model related to detection, there is model related to profiling the body to a three-dimensional space, and then also the tracking, right? So making sure that you are tracking the same person throughout the video. But now these kind of solutions are available, and it's giving the kind of human biomechanics data in a very economical way compared to say a sensor-based technology. And this is where the computer vision is having a big advantage. So we talked about only about the advantages. It's there is nothing called all green. So there are some area where there are limitations, and where the technology or the solutions kind of they fail to satisfy the end user. And this is where the technology companies have to make sure that first of all, they educate their customers about the limitation of the technology, and not try to oversell that. So one simple limitation which we all know is kind of the generalization, right? So whenever we talk about the AI, all we get in the sense is a general human-like behavior of technology. So that kind of generalization is still not available, and I personally I feel is still decade away. So making sure that our technology, our solution work in the particular environment for which it's supposed to work, and rather than making it work in the environment which is not trained for, the data was not available, the model has not seen that. So those kind of scenarios has to be avoided. So those kind of boundary conditions, right? So if I'm trying to detect something, if our model is trying to detect a particular class of vehicle, and I think that it should detect almost every vehicle, so that's where the problem comes in, and that's where most of the time the model fail. Similarly, the algorithm limitations are there. So especially there are huge cases, especially with the say action recognition of the human being. So these are the huge cases which is still, yeah, I would say in progress. So it's still in the lab stage, and to commit to the real production value, the lot of work has to be done. The model has to become deployable. The model has to become to a state where it's accurate enough for people to have a faith in that. So there are different kind of models where there is still a lot of work has to be done before it gets into the production and deployment phases. The hardware side, of course, there is the things is happening, but we still desire that the hardware becomes available in a cheaper and in a cheaper way, and whenever we need. So especially I can talk about the graphics card and GPUs. Now, thanks to cloud computing, if you have the resources, you can buy that. But earlier we used to buy those graphics card ourselves, and due to all the Bitcoin mania, all the miners used to get the graphics card rather than the people who are looking to research or looking to work on the use cases, which are the different kind of applications. So yeah, the hardware dependency is still there. One thing where the organizations and industry is very they take time before getting convinced with the data privacy, right? So if we are sourcing data from, say, a CCTV camera inside a factory, inside a sensitive installations, it has to be treated in a proper, safe manner, making sure the leakage and the conditions are good, and people, especially the end user, is satisfied that their data is not getting compromised. And that's why the cloud, people want to move to the cloud for these kind of use cases, but the biggest restriction is about the data privacy side. So what we have seen is, especially in the India case of India, people still want to be on premise and don't want to expose their cameras to cloud computing. So this is an ongoing field that we have to convince from the industry point of view that your data is safe and secure. So I hope I gave you some idea about the work which I'm doing, and I'm very excited about. So we have 10-15 minutes for discussions, for questions, right? So it should not be one-way communication. I'm making sure that
Hrishikesh, thank you very much. So any questions from audience side? It was a very interesting talk, so definitely there should be some questions. Okay, I think people are thinking about that, means what, especially they may be compiling the queries. So meanwhile, I'll just request you to please throw some light on the application security, the application which you have made for such type of basically the vision and monitoring. So what about the security feature of those applications?
Sure. So there are 2-3 things which broadly which we have to keep in mind, right? So one is when we are sourcing the data, it has to be sourced in a safe manner, right? So your application, whatever app you are using, that has to be safe in proper manner. The other thing is, like when the data is getting when the data is in transit, that has to be proper SSL secured. It has to make sure that the APIs are secure before it gets transferred to all your servers. The other thing which comes up is about the data privacy, and especially in the case of Europe, the GDPR rules, right? To make sure that the personal information of the people are not getting processed in an unsecure way. So in the case of our ergonomics related solutions, I can talk about our case. What we have done is we have tried to minimize the personal information. So we don't need a person's email, phone, age, name, etc. to do your risk assessment of your work. So all we need is a video feed, where also we try to mask the face of the person. So the user who is using the application, they should not able to see the face of the person. So to make sure that we minimize every identity which can be taken from the person, and which could anyway harm or compromise the privacy of an individual, and that has to come into the part of the application security. So from your app to your cloud server to your data security practice, that has to be there. The other thing on the application security part is most of the organizations are making sure that you have to be ISO certified, especially ISO 27001 or SOC certified. So the leakage is kind of restricted. Did I answer your question, or you had something else?
Yeah, Rishikesh. Yeah. So any questions from audience side? Professor Saurabh, I think you might be able to write in text. Yes. So I think he's he's writing.
Yeah, not so it.
Yeah.
Yeah.
He's typing.
Sure. And even after the meeting, after this talk, you can always reach out to me on my email is shared, hkumar@cerebrumedge.com. So if you have a question about the technology or about the use case, I will be happy to answer.
Question. Yeah, we are having a question from Professor Saurabh. Can you elaborate how privacy interfaces with security?
Okay, so I think what he's talking about, the question's context, if I'm sure, is how do we make sure that privacy is not violated in the case of a security situation or unsafe condition. I think that's what. Yeah. Okay. So it depends on application to application. So if the application is say to make sure that your workstation is not injury prone, right? So and to make sure that you interact with your environment or your workstation in a safer manner. So to do that, right now you don't need any kind of a individual detail. So all you need is how the workstation is designed, how the individual is doing the movement, how the individual is interacting with the work. So you don't need the personal level of data. The personal level of data where the things get a little interesting, or where it gets little dicey, is say there is a violation. So you are, for example, not wearing your protective equipment. In that case, what has to be done? So in that case, some organization, they want the supervisor to be informed of that particular area, because there is a danger, right? So the person will be informed that in the particular area ABC, in this camera zone, there are two violations where people are not wearing, say, a protective equipment, which could lead to those injuries. We Most of these applications, they are still we are not identifying the person. It's whether it's Ram or Ramesh, we are not identifying the person, but we are kind of giving the alert to the area in charge or the safety in charge, and that person has to be aware of that. So that's the case. Though inside, it's still not, you cannot say 100% sure, especially if the person knows about that particular zone, they will know the person who is working there. So that kind of details you can still not hide, and probably it's in some way it also helps to make sure that the person remains safe. So that's where the things are right now. Do you see GDPR being a problem for building security applications, since it restricts severely what data can be collected and processed, especially individual data? So this is based on the application. So what we have seen, and since we have worked with our European partners, so one thing is like before even demo, they want to make sure that the applications are GDPR compliant. Ideally, that slows down the innovation process, to be very frank. Like for us to go through all those compliance related requirements to make sure that the things are ISO compliant, etc., it slows down the innovation related process. And if I want to try something new, it's very difficult unless you again go through that approval process. So that kind of slows down. But at the same time, there are enough things which you can add in your applications to make sure that it's GDPR compliant. So unless this, so there are multiple concepts. So one is like data minimization, so personal data minimization. So unless you don't require to figure out what's your name and where you are from and what your gender and all those details, you should not collect that. So making sure that your application is minimizing the data which you are taking from individual, right? So unless the data is really required, but for different applications, for fintech applications, of course, those are required, and that has to go through a different kind of regulation process. But for our safety related standard, we are trying to make sure, one, minimizing the data which we are capturing, especially about the individual. Second, wherever possible, we are trying to make sure that we mask or pseudonym all that data. So get the information, but making sure that we kind of blur the other information, something which is not required. So we don't need to, for example, show you the face of the person who is doing that work. So we kind of mask that. So minimizing the data, making sure we are masking those information and collecting only the things which are required. That makes it a little easier, but still it's a compliance with, so you have to follow that.
Hello. So I think Hrishikesh has answered the question. Yes. So Professor Saurabh has already thanks to you. So any questions? Any other questions from audience side? Okay. So if there are no questions remaining, so I'll be thanking Hrishikesh for sparing his valuable time with us and making this particular event, this particular iteration of CJD very interesting and successful. So thank you, Hrishikesh. So we have recorded your session, and we are going to host this particular recording on our YouTube channel, which can benefit our students and the faculty members and employees of our institute.
Thank you. Thank you for having me.
Yeah.
Very nice talking.
Anything else you want to ask from us? Then it will be a pleasure for us to answer.
No, we are good. So I'm available on my email, and you can also connect me through LinkedIn. So any kind of question which is in our domain, technical or something.
Once they will be seeing your this recording, this lecture recording, definitely they will be coming up with a question and they will be asking about the contact because it's a really interesting thing how you are making all these things possible of monitoring and making such real application for computer vision. So
thank you.
Thank you very much. So thank you very much for joining us and making this event successful. Thanks.
Have a good day.